studied in Arabic or in English? In Arabic, yeah. And you studied in English, so you should know it then. Yeah. But you studied in Korean.
I didn't study,
but you know these words.
Yeah, I know.
Amazing. All right, scalars and vectors. If you want to write this down, please. Yep. Do you know scalars and vectors? Maybe.
Yeah, maybe.
Oh, yeah, sorry. What do you think? Do you know these?
Maybe. I hope so.
And of course you know them. Yeah. Okay. Let's have a look now. Ready? Yeah. Okay. So we'll look at scalars, magnitudes and directions and so on. Right, so tell me if you remember these in Arabic. A scalar is or in Korean. A scalar is a quantity, is a thing that has only a magnitude. Now what did magnitude mean? Do you remember this? Size, yeah. So scalar has only a size and no direction. For example, walking at 1 step per second is a scalar. However, walking at 1 step per second to my home is not a scalar. Why not?
Because it's showing the direction.
It has a direction to my home. So scalar does not have a direction. Okay. Now, this is a very common exam question. They love asking what is a scalar, what is a vector. So you definitely need this definition. Okay. Now, tell me, Arabic? Oh, he studied in English. He can't help you.
No, I'm just making sure it's the same as one.
You think you know it, yeah.
We can Google Translate.
No, it's okay. You won't need it for the exam. You just need the English name.
Yeah.
So, if you can write this definition down, scalar. Do you have double chemistry this morning, was it?
No.
Oh, double maths. Okay, yeah. And how's the maths? Easy, difficult?
Easy, good.
It's okay so far.
So
far. So how far, or how much have you done in the maths then? You did equation of the line?
We have done 3 chapters.
3 sections.
Yes.
Okay.
We haven't finished the third one.
Oh yeah, okay.
We have finished it today. Degree system, 2 degree systems, we have done it.
We didn't take the second method.
What's the
Yeah.
second method?
Substitution, we have done it. The last one was the substitution method.
Oh, okay, alright.
The very last question on that worksheet you don't have to do.
Yeah.
So it's just, he
Yeah.
told you that.
1 and 4.
1,
we
2
don't
and
have
3.
to- There are 4 questions, we
Yeah.
don't have to do 1, and the 4th one, 2 and 3.
You don't have to do 1, true, yeah. Yeah. I made all those worksheets, so I have intimate knowledge about all the lessons. So if the questions seem too difficult, you can thank me.
So far they are.
So far they're okay. Yeah. All right. Do you have this?
Yeah.
Yeah. All right. So of course, scalar is one, and you can probably guess what the next one will be. Vectors. Yes.
What is that?
Vector. Huh?
What is that?
With a direction. Yeah. So a vector is a quantity that has magnitude and direction. For example, walking 1 step per second to my home is a vector. However, walking 1 step per second is not a vector because no direction. It's like scalar actually. Yeah, because it has no direction. Got that? Yeah? Okay. So scalars and vectors then. Continue? Andy? It's okay? Are you sure? Okay. Well, the first sentence is most important. A vector is a quantity that has magnitude and direction. As long as you have that, it's okay. You don't have that. We'll wait a moment. Do you have that sentence?
Yeah.
Are you sure? Don't be shy. We're all friends. Yeah, okay, good. There are two famous examples of scalars and vectors, and they are speed and velocities. Yeah. So most native speakers think that speed and velocity is the same thing. Okay? But they're not. They're different. They're different, yeah. So for us, they're different. They're not the same thing. They're not. In fact, they're very different for physics students. So what is the difference? So the difference is, well, speed is...
Speed is the meter, like...
Yeah, but speed is a vector or scalar.
Vector.
Scalar. Speed of an object is the rate of change of distance per unit time. For example, 50 kilometers per hour. So you see, there's no direction here. So this makes it a scalar, or 10 meters per second, or 1 step per second.
It's like the difference is it's got kilometers.
No, the only difference is speed has no direction. Notice how I don't tell you where the car is going. So this makes speed a scalar. And as a formula, this is the formula. Velocity has a direction. So for example, 50 kilometers per hour is a scalar. 50 kilometers per hour north is a vector, is a velocity. So just remember, velocity has a V, it's a vector. Speed has an S, it's a scalar.
Yeah.
And that's the first time I actually realized that, okay? I've never noticed that before. So it's easy to remember. Velocity, V, vector, speed, scalar, S. So you should never mix them up now, okay? And I don't know why after 9 years, that's the first time I noticed that. Now, I was just talking to Manchester yesterday. Manchester are the people who designed the course. And in semester 1, you have your coursework 1 for physics. And coursework 1 for physics is you have to write an essay. Now, the essay can be about some physics topic. And we'll talk about this in a couple of weeks. But I'd like to pick a topic that everybody is interested in, so it's something easy to write, okay? So, just maybe over the next week or two, just have a think about what type of essay you would like to write, okay? Because I think I need to pick the same topic for the whole class. So because everybody's doing engineering, maybe we can find something with that then, okay?
Mechanics,
It can be anything, something that everybody might like.
Okay, I'm confused with, that what we have to write in means. I know how to write an essay, but in physics, it's strange to write an essay.
It is strange, and I don't know what to do either, because in previous years, you didn't have to write an essay, and this year, it's new, you do have to write an essay. So yes, I can't help you either. I'll have to figure it out too.
Like we have we are having like exams, it's numerical,
Yep.
theory.
Yeah.
This is the main physics, or you
Oh,
can
yes.
say chemistry. But
I
you know,
agree
the
with you.
essay.
I don't have an idea what to do. I need to talk to the other teachers who do write essays in class. But don't worry, we'll figure it out. Okay, so velocity of an object is the rate of change of its position or displacement. So the difference is, distance is how far, but what's position or displacement? Position is where. So like destination, location, like this. So that's the big difference. So for example, velocity will be 15 kilometers per hour to the north. That's your position. 50 kilometers south, 50 kilometers to my home. These are velocities. So the difference is 50 kilometers due north, 10 meters per second to the finish line, 1 step per second to my home. They're all velocities. And the formula, velocity, is the change in displacement, the change in position divided by time. We will talk about this in much more detail in a different lesson.
The word that I said in Arabic is actually velocity, it's not vector. It's actually velocity.
Ah, but velocity is a vector, so
Oh,
yeah,
yeah,
it's okay.
close.
Yeah, close, yeah. Okay? Yeah.
Can you get full marks in math?
Yes, but it's quite rare. So I get 100% in the exam. 100% in semester 1 exam is possible. That happened a couple of times. But there's only ever been one student, and she got 100% in the final exam, and that's only ever happened once in 9 years. So, I mean, you can get like 99, 98, people have done this, but 100% doesn't happen often. In fact, in the final exam, I've only seen that happen once. Final exams, tricky. It's tricky, yeah. You could get 100% in semester 1 exam because it's smaller. And it's good to aim for 100%, but you would impress me if you got 100%, yeah.
Hope so.
Yes, oh, you can hope, of course. You can hope, yes. All right, we have this? Yep, okay. Right, so more definitions will come later. Now, we need to talk really about displacement. Does anybody feel they know what displacement is?
It's the distance between 2 points.
Kind of, not quite. What do you think?
Like some like 2 points, like one point is far from the other.
The
Yeah.
shortest distance between 2 points.
You're getting closer.
That's a straight line.
Yeah, well, there is a kind of thing like that. I'll tell you. Look, displacement is a vector, and the way I think of it is it's the position of an object at a point in time. So, for example, don't write this just yet. For example, Andy's displacement vector is this: 2 meters in front of me. Your displacement vector is 3 meters at 45 degrees. Displacement is a vector that points to where the thing is. So that's one displacement vector, this is another, and another. So it's not, I think if I draw it, for example, Let's make a little scene. There's the grass. And so here is the start. So this man, he walks 1, 2, 3 meters, and then back 1 meter. So in total, how far did he walk? The distance he travelled is 4 meters. His displacement is not 4 meters, it's 2 meters, yes. His displacement is 2 meters right. And that's important because it's a vector. You have to give a direction. So the difference is a small difference. Now sometimes it's the same. For example, if he goes 1, 2, 3, 4, what's his distance? 4 meters. And his displacement, which we usually use S, is 4 meters right. Now if you don't want to write right or left, you can just write plus or minus.
Okay.
So to the right is plus and to the left is minus then. Okay, so this is displacement. So displacement is a position vector. For example, the ship is 2 kilometers to the east. That's the displacement. The man is 3 kilometers to the east of his home. That's also displacement. So here is another definition to write down. Got that? Yeah? Yeah? Okay. Right. Terms like homebound. Actually, I should have checked. What does homebound mean?
Staying at home.
I know why you think that, but no, it's not that. And I know exactly why you think that, because in English there's housebound, and housebound means staying at home. But funny enough, homebound doesn't. Anyone know homebound?
Outside the home.
No, homebound means to your home. So if I said I am homebound, it means I'm going to my home. I am northbound, that means I'm going north, yeah. That's funny, I never thought about that, but you're right. Housebound means you're stuck in the house. Homebound is the opposite, it means you're going to your home. That's interesting. And to the finish line. These directions are not mathematical. They're not. They're words. So we need something more precise. So the way we do that is we represent vectors by an arrow. Like so. So for example, what this vector means is the direction is this way, and the size of the direction is the length. So for example, if this is 10 meters northeast, what would this one be? 5 meters northeast. And this one would be 5 meters east, and this would be 5 meters north. So you can represent the vector as a picture, as an arrow, rather than as words. Which is what we do, of course, because this is not English class, this is physics and maths business, okay? So the key vocabulary is magnitude is the length, direction is where it points, this is called the head of the vector, and this is called the tail of the vector. So I need you to draw this, okay? Actually, that's a little bit blurry. That's much better. Okay, we drew this? Yeah. Okay. The length represents the magnitude and where it points represents the direction. Yeah, okay. Right, so what we'll do is, we'll do these together. I think it's kind of easy. The first one, 5 meters per second north. We want to draw this vector. So this could be, for example, 5 meters per second north. But if I do 4 meters per second east, it needs to be a little bit shorter. So this could be, for example, 4 meters east. 5 meters west will be the same length as this. So it could be something like this. This could be 5 meters west. 1 meter per second south. So that could be something like this. That would be 1 meter per second south. Now, 3 meters per second, 30 degrees north of east. North of east.
It's up and then it's going this way, 30 degrees.
The 30 is here,
Yeah.
north of the east. 3 meters per second, north, 30 west.
Yeah.
This way.
Not the same.
Yeah.
Opposite.
If we have north, south, east, west, so north 30 west is here.
Yeah.
That's the 30 there. North to west. What one's that? That's F. Bearing of 30 degrees. But yeah, what is bearing of 30 degrees? So
Like 30
1 meter per second bearing 30 degrees.
It's the same,
As this one?
we'll draw a right angle, then we'll show the 30 degrees.
Where? Top, bottom, left or right?
Right.
This is a new word, is it?
Yeah.
So bearing we measure from the north, clockwise.
Okay.
This is bearing. Now, what you said is actually the next one. If I just said at 30 degrees, that is from the right angle triangle. So the next one, the last one, H, what is it? 2 meters per second. Oh, that's too big. Sorry, that should only be 1. Doesn't matter. The last one, if I just said at 30 degrees, it's like in math class, you remember with the circle, and you measure the angles out from here. Yeah. So just be careful. Now the good thing is in the exam they don't use this vocabulary. They just use like this or like this. But just in case, it's good to see all the possibilities. So you don't need to write that down. I think you all got the idea. And there'll be some questions to practice anyways in the homework. So what we'll do is I'll make some coffee and let you try these for a couple of minutes, and then when I come back in 5 minutes, we'll just start the next lesson. Now you'll probably be finished before I come back in 5 minutes, because I just need you to draw. That's it, okay?